The selection of 75 degrees Celsius as ambient temperature for service equipment in Pennsylvania is rooted in historical data and established industry standards. While the National Electrical Code, or NEC, permits the utilization of 90 degrees Celsius for service equipment, Pennsylvania has opted for a more cautious approach by adhering to 75 degrees Celsius. There are several factors influencing Pennsylvania's preference for a lower ambient temperature. Firstly, safety is paramount. Employing a lower ambient temperature significantly reduces the risk of equipment overheating, thereby mitigating potential safety hazards. Secondly, reliability is enhanced. Equipment operating at a reduced temperature is less susceptible to premature failure, ensuring longevity and consistent performance. Thirdly, code compliance is maintained. The NEC sanctions the adoption of 75 degrees Celsius for service equipment, affirming Pennsylvania's adherence to regulatory standards. Conversely, New Jersey permits the use of 90 degrees Celsius for service equipment, potentially attributed to the state's comparatively warmer climate. Ultimately, the determination of the appropriate ambient temperature for service equipment hinges on engineering judgment. While a lower ambient temperature offers advantages in terms of safety and reliability, considerations such as cost and other factors may influence the adoption of a higher ambient temperature. The National Electrical Code, or NEC, serves as a comprehensive guideline for electrical installations, encompassing a wide range of safety standards and best practices. Understanding the rationale behind specific code provisions is crucial for ensuring safe and compliant electrical systems. Temperature ratings of conductors and equipment play a vital role in electrical safety. Conductors are typically insulated with materials that are rated for specific maximum operating temperatures, such as 60 degrees Celsius, 75 degrees Celsius, or 90 degrees Celsius. These temperature ratings indicate the maximum temperature at which the conductor's insulation can safely operate without degrading or posing a safety hazard. Similarly, electrical equipment, such as circuit breakers, transformers, and panels, are also assigned temperature ratings. These ratings specify the maximum ambient temperature at which the equipment can operate without exceeding its design limits. When selecting conductors and equipment for electrical installations, it is essential to consider the ambient temperature in which they will be operating. The ambient temperature refers to the temperature of the surrounding environment. If the ambient temperature is too high, it can cause the conductors and equipment to overheat, leading to insulation degradation, reduced lifespan, and potentially even fire hazards. The NEC provides guidelines for directing conductors and equipment when they are installed in high ambient temperature environments. Directing involves reducing the allowable ampacity of conductors or the rating of equipment to compensate for the increased ambient temperature. This ensures that the conductors and equipment operate within their safe temperature limits, even in hot environments. In addition to ambient temperature, other factors can also affect the temperature of conductors and equipment. These factors include the amount of current flowing through the conductors, the proximity of other heat-generating equipment, and the ventilation of the installation. It is important to consider all of these factors when designing and installing electrical systems to ensure that they operate safely and reliably. The NEC specifies requirements for conductor ampacity based on insulation temperature rating and ambient temperature. Tables like NEC Table 310.15. The 16 provide ampacity values for various conductor sizes and insulation types at different ambient temperatures. Correction factors are applied to these ampacity values when the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit. For example, if a conductor with a 75 degrees Celsius insulation rating is installed in an ambient temperature of 40 degrees Celsius, a correction factor from NEC Table 310.15 B2 must be applied to reduce its ampacity. This ensures the conductor does not exceed its rated temperature. Similarly, NEC Section 110.14 C1 addresses terminal temperature limitations. Equipment terminals are typically rated for either 60 degrees Celsius or 75 degrees Celsius. Conductors connected to these terminals must be sized based on the terminal temperature rating, not the conductor's insulation temperature rating if it is higher. This prevents overheating at the terminals, which can lead to loose connections and potential fire hazards. For instance, if a circuit breaker terminal is rated for 75 degrees Celsius, the conductor connected to it must be sized according to the 75 degrees Celsius ampacity column in NEC Table 310.15. D16, even if the conductor has a 90 degrees Celsius insulation rating. Enclosure types also play a role in temperature management. Enclosures protect electrical equipment from environmental factors such as moisture, dust, and corrosion. However, they can also trap heat, increasing the internal temperature of the equipment. NEC Section 312.6 specifies requirements for the minimum size of enclosures based on the number and size of conductors and equipment they contain. Adequate enclosure space is necessary to allow for proper heat dissipation and prevent overheating. Ventilation is another important consideration for temperature management. Proper ventilation helps to remove heat from electrical equipment and prevent the buildup of hot spots. NEC Section 408.20 addresses ventilation requirements for switchboards and panel boards. These requirements specify the minimum clearances and ventilation openings needed to ensure adequate cooling. In summary, temperature ratings, ambient temperature, conductor ampacity, terminal temperature limitations, enclosure types, and ventilation are all critical factors in ensuring the safe and reliable operation of electrical systems. Adhering to NEC guidelines and best practices for temperature management is essential for preventing overheating, insulation degradation, and potential fire hazards. Understanding the differences between 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius rated wiring and equipment is crucial for safe and compliant electrical installations. These temperature ratings indicate the maximum operating temperature that the wire or equipment can withstand without degrading or posing a safety hazard. Firstly, 60 degrees Celsius rated wiring is typically used for general-purpose wiring in residential and commercial buildings. It is suitable for applications where the ambient temperature is not excessively high and the current load is relatively low. Examples of 60 degrees Celsius rated wiring include Type TW and Type UF cables. Secondly, 75 degrees Celsius rated wiring is commonly used for branch circuits and feeders in residential, commercial, and industrial buildings. It offers a higher temperature rating than 60 degrees Celsius rated wiring, making it suitable for applications where the ambient temperature is higher or the current load is greater. Examples of 75 degrees Celsius rated wiring include Type THW and Type XHHW cables. Thirdly, 90 degrees Celsius rated wiring is typically used for high temperature applications, such as in industrial settings or for specific equipment wiring. It provides the highest temperature rating among the three types, making it suitable for environments where the ambient temperature is very high or the current load is very heavy. Examples of 90 degrees Celsius rated wiring include Type THHN and Type XHHW-2 cables. When selecting wiring for an electrical installation, it is essential to consider the ambient temperature, the current load, and the equipment termination temperature ratings. The wiring must be rated for at least the maximum operating temperature that it will experience in the installation. It is also important to ensure that the equipment terminations are rated for the same temperature as the wiring. If the equipment terminations are rated for a lower temperature than the wiring must be sized based on the lower temperature rating. In addition to wiring, electrical equipment such as circuit breakers, transformers, and panels also have temperature ratings. These ratings indicate the maximum ambient temperature at which the equipment can operate without exceeding its design limits. When selecting equipment for an electrical installation, it is essential to consider the ambient temperature in which the equipment will be operating. The equipment must be rated for at least the maximum ambient temperature that it will experience in the installation. It is also important to ensure that the equipment is properly ventilated to prevent overheating. In summary, 60 degrees Celsius, 75 degrees Celsius, and 90 degrees Celsius rated wiring and equipment offer different temperature ratings for various electrical applications. Selecting the appropriate wiring and equipment based on the ambient temperature, current load, and equipment termination temperature ratings is crucial for safe and compliant electrical installations. The National Electrical Code, or NEC, provides specific guidelines for selecting and installing wiring and equipment based on their temperature ratings. Understanding these guidelines is essential for ensuring the safety and reliability of electrical systems. When dealing with electrical installations, the concept of ambient temperature plays a crucial role in determining the safe operating conditions for conductors and equipment. Ambient temperature refers to the temperature of the surrounding air or environment in which the electrical components are installed. It is essential to consider the ambient temperature when selecting conductors and equipment because excessive heat can lead to insulation degradation, reduced current carrying capacity, and potential safety hazards. The National Electrical Code, or NEC, provides guidelines for dirting conductors and equipment based on ambient temperature. Dirting involves reducing the allowable ampacity of conductors or the rating of equipment to compensate for the increased ambient temperature. This ensures that the conductors and equipment operate within their safe temperature limits, even in hot environments. The NEC specifies different ambient temperature correction factors for various conductor insulation types and equipment. These correction factors are used to adjust the ampacity of conductors or the rating of equipment based on the actual ambient temperature. For example, if a conductor with a 75 degrees Celsius insulation rating is installed in an ambient temperature of 40 degrees Celsius, a correction factor must be applied to reduce its ampacity. The NEC also specifies requirements for the location of temperature sensors used to measure ambient temperature. The temperature sensors must be located in a representative area where the electrical components are installed. They should not be placed in direct sunlight or near heat-generating equipment, as this can lead to inaccurate readings. In addition to ambient temperature, other factors can also affect the temperature of conductors and equipment. These factors include the amount of current flowing through the conductors, the proximity of other heat-generating equipment, and the ventilation of the installation. It is important to consider all of these factors when designing and installing electrical systems to ensure that they operate safely and reliably. Proper ventilation is essential for dissipating heat and maintaining a safe operating temperature for electrical components. The NEC specifies requirements for ventilation in various types of electrical installations. These requirements specify the minimum clearances and ventilation openings needed to ensure adequate cooling. In summary, ambient temperature is a critical factor in determining the safe operating conditions for conductors and equipment. The NEC provides guidelines for dirting conductors and equipment based on ambient temperature, and it is essential to follow these guidelines to ensure the safety and reliability of electrical systems. Proper ventilation and consideration of other heat-generating factors are also important for maintaining a safe operating temperature. The choice between using 75 degrees Celsius or 90 degrees Celsius rated conductors in an electrical installation depends on several factors, including the ambient temperature, the termination temperature ratings of the equipment, and the specific requirements of the National Electrical Code, or NEC. Firstly, ambient temperature plays a significant role in determining the appropriate conductor temperature rating. If the ambient temperature is high, it may be necessary to use 90 degrees Celsius rated conductors to ensure that the conductors do not overheat. The NEC provides ambient temperature correction factors that must be applied to the ampacity of conductors based on the ambient temperature. Secondly, the termination temperature ratings of the equipment must also be considered. Equipment terminations, such as circuit breakers and terminals, are typically rated for either 60 degrees Celsius or 75 degrees Celsius. If the equipment terminations are rated for 60 degrees Celsius, then the conductors must be sized based on the 60 degrees Celsius ampacity column in the NEC, regardless of the conductor's temperature rating. If the equipment terminations are rated for 75 degrees Celsius, then the conductors can be sized based on the 75 degrees Celsius ampacity column in the NEC, provided that the ambient temperature is not too high. Thirdly, the specific requirements of the NEC must be followed. The NEC provides detailed guidelines for selecting and installing conductors based on their temperature ratings. These guidelines must be followed to ensure that the electrical installation is safe and compliant. In general, 90 degrees Celsius rated conductors can be used in most applications, provided that the ambient temperature is not too high and the equipment terminations are rated for at least 75 degrees Celsius. However, it is always best to consult the NEC and a qualified electrician to determine the appropriate conductor temperature rating for a specific electrical installation. The use of 90 degrees Celsius rated conductors can offer several advantages over 75 degrees Celsius rated conductors. Firstly, 90 degrees Celsius rated conductors have a higher ampacity than 75 degrees Celsius rated conductors of the same size. This means that smaller conductors can be used for the same current load, which can save on material costs and reduce the size of conduit and raceways. Secondly, 90 degrees Celsius rated conductors are more resistant to heat than 75 degrees Celsius rated conductors. This means that they can operate safely in higher ambient temperatures without dirting. However, it is important to note that 90 degrees Celsius rated conductors are typically more expensive than 75 degrees Celsius rated conductors. In summary, the choice between using 75 degrees Celsius or 90 degrees Celsius rated conductors depends on several factors, including the ambient temperature, the termination temperature ratings of the equipment, and the specific requirements of the NEC. It is always best to consult the NEC and a qualified electrician to determine the appropriate conductor temperature rating for a specific electrical installation. The National Electrical Code, or NEC, provides comprehensive guidelines for the safe and reliable installation of electrical systems. These guidelines cover a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Adhering to the NEC is essential for ensuring the safety of people and property from electrical hazards. The NEC is updated every 3 years to reflect the latest technological advancements and best practices in the electrical industry. It is important for electricians, engineers, and other electrical professionals to stay up to date on the latest edition of the NEC to ensure that their work complies with current safety standards. The NEC is not a law itself, but it is often adopted by state and local governments as part of their building codes. This means that compliance with the NEC is legally required in many jurisdictions. The NEC is organized into chapters, articles, and sections. Each chapter covers a specific area of electrical installation, such as wiring methods or overcurrent protection. Each article provides more detailed requirements for a specific topic within the chapter. Each section provides specific rules or guidelines for a particular aspect of the topic. The NEC uses a system of tables and figures to provide detailed information on various electrical parameters such as conductor ampacity, conduit fill, and grounding electrode size. These tables and figures are essential for properly designing and installing electrical systems. The NEC also includes a glossary of terms that defines many of the technical terms used in the code. This glossary is helpful for understanding the meaning of specific requirements. The NEC is a complex and comprehensive document, but it is essential for ensuring the safety and reliability of electrical systems. By adhering to the NEC, electrical professionals can help to prevent electrical fires, shocks, and other hazards. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These include standards from organizations such as the Institute of Electrical and Electronics Engineers, or IEE, and the National Fire Protection Association, or NFPA. It is important to be aware of all applicable standards and regulations when designing and installing electrical systems. The NEC is a valuable resource for electrical professionals, but it is not a substitute for proper training and experience. The electrical work should only be performed by qualified individuals who have the knowledge and skills necessary to do the job safely and correctly.